My name is Eddie Yanas, and this is my assignment 1 for GAM398. So for the first question, I had to make that star shape. So what I did was set the right vector points. So based on the screen space on the triangles that we had before, I just found the correct points and set them up appropriately. And then in my indices list is where I set the right indices, making sure they're counterclockwise so that they get shown. So if I run this here, I get the exact star shape that was there for question 1. And then for question 2, I had to create the n-sided polygon. And for that, I have a constant numverts, which I can change this number to whatever I want. Right now it's 7. And then num triangles, which is the amount of triangles you're going to get is equal to the number of verts you have minus 2. So if I scroll down over here to find it, in order to create my verts, I have to create a list as big as the vertices that I need and put in this equation. So I need the radius times the cosine of 2 pi I being the vertice number or vertex number, and then divide that all by the number of verts that I have so that they're evenly spaced around a circle. And then for y, I do the same, but I use sine of 2 pi divided by the number of vertices. And then I set that vertex equal to x, y, and then 0 for the depth. If I scroll down to indices, the amount of indices I'll need, of course, is 3 indices per triangle, so num triangles times 3. I set a counter before my loop so that I can keep track of the 2 indices I need besides the one that they start from. So if I start from 0, I'll need the one after it and the one 2 spaces ahead of it, and I'll need those in counterclockwise order. So my for loop runs through as big as the num triangles times 3, which is how many indices I need, and it'll skip ahead by 3 each loop. So the first one will be 0, 1, 2, and then 0, 2, 3, 0, 3, 4, 0, 4, 5, etc. And then that's the correct order of the indices counterclockwise. And that's pretty much it, because the triangles are created the exact same way regardless of how many vertices I have. So if I run this, I should get 7. And they all start from the first point, so this is where the vertices spawn. So 1, 2, 3, 4, 5, 6, 7 with 5 triangles inside. Close this. I'll change this to 12 now, as per the example. And now we'll have 12 vertices with 10 triangles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Close this out. I can have a bigger number like 42. Run this again. And I'm not going to count, but you can see the changes reflected appropriately. And right now I have it in wireframe so that I could see the triangles. But I could change the fill to solid, I believe that's what it was, and have this fill with solid instead of wireframe. And there you go, pretty much as an oval. And then for the 2 or 3 questions for the further work section. So for my one triangle demo, I noticed that changing the depth of the vertex to 2 made the pipeline at the, I believe, rasterization stage and the pixel shader stage, I'm sorry, call the section of the triangle that's not seen because it's past the depth of the far plane. So the far plane is 1 at the moment. If the vertex z depth is at 1, it will show, but if it's anything past 1, it'll get called, and that it'll like triangulate the shape and cut off that triangle. So I will set this to 0, so this is where the trapezoid should show up. And the reason being is if you can see this sectioned into 4 triangles, then the top triangle here will be called. And then if I do the same for the bottom right, then those two triangles will be called, and we're left with two smaller triangles. So here's just one triangle, sorry. So the three over here are called because they're further off in the distance. And this reason being is I believe there's the topology here is set to triangle, which means that the way that it's going to be called is by sectioning off the shape into triangles. And that's why when the depth is greater than the far plane, it just won't show, but it'll cut off the shape at the closest triangle. And then for the next question, the viewport, if I change these numbers to larger numbers than 0, which is what they were, I see that the triangle is in this position. Of course, they used to be at 0. So it's the same scene, I guess, not scene, but it's the same image being rendered, but a different section of it. You'll see here the triangle has moved. But the reason that this is useful is if we want to show two parts of the same image in separate sections of the window. So for like a picture-in-picture type of thing where we want to show one section of a map and then another section of a game overlaying on top of it, or vice versa. And we can have different viewports that way. So we don't always have to be seeing the entire picture. We can section off what we want to see and what we don't want to see. And then also have two viewports or more than two. And then for the third question, the DXGI formats, I was looking into them, and so it turns out that they're basically number formats that signify the channel type, so how many bits are associated through that channel. So for the R8G8, basically there's 8 bits for the red, green, and blue channels. And it's an unsigned normalized integer. That's 32-bit, so that'd be 8 times 4, of course. And then for R16 DXGI format, that's a single unsigned 16-bit format that only supports 16 bits for the red channel. So this would not be RGBA, so there's no alpha channel for this. And there's RGBA for the other format. And this is used, I believe, here. So here's the R16 format for a single color 16-bit channel, which is what I believe this is being used for. When we don't need that much color information. And when we do need more color information, we use R8G8B8's A8 unorm, which is set here once we first initialized Direct3D. And we set the buffer format to that. So if we know the target of what we want to render, the type that we want to render on our buffer, we know how many bits we need per channel and what kind of channels we need. We set that DXGI format, and that's how we basically target the type of buffer format that we need. And that's pretty much it. That's what I got out of the question anyway. So that's all for my first assignment, and thank you.